Hello and welcome back to me doing the 2022 Practice Exam 3 MCQs with explanations. I will be cutting down on the amount of problems on this video so it's not 30 minutes long like the last couple ones have been. So I'll be doing 41 through 45. So starting off with number 41. 41 asks us how mechanical energy changes between time 0 less than t equals 1 and t is less than 1, less than t equals 2. The key wording in the question, though, is block spring system. So the Earth is not part of this. So any force exerted by the Earth is going to be an external force and will cause a change in mechanical energy. So what this shows us here is that there is a block on a spring which is attached to a wall, and that the block goes off here, off the table at time t equals 1. It also says that there is non-negligible friction. So we're going to have to factor in friction into how our mechanical energy changes. There's three forces total. We have normal force, gravity, and friction from 0 is less than t equals 1. So we know mechanical energy is equal to potential energy plus our kinetic energy. However, mechanical energy does not factor in friction. So when there's friction present, mechanical energy will decrease because friction dissipates mechanical energy. So in other words, it just makes it smaller. So from 0 is less than t is less than t equals t1, we know that it is going to decrease. So this gives us our answer, D. However, the reason why it increases is because of after t equals 1. It's because of the language present in the problem. The block spring system, since it falls off here, it's the block the spring. So the block is being pulled by a force of gravity. The force of gravity is not part of the system. So that's an external force, which means our mechanical energy is going to increase as time goes along. Number 42. Number 42, we're shown an inclined plane, angle theta, with a block moving up it with mass m, and our positive x-axis is going to be the angle of the inclined plane, and our y-axis is going to be like that. It tells us that there is a kinetic friction force on the box with magnitude F, and that it asks us to find the acceleration. To find acceleration, we're going to have to find F in x direction. F in x direction is going to be equal to mass times acceleration, which is going to be equal to negative force of friction because our x positive is this direction, and the force of friction is going to be going this direction to counteract the motion of the box. Negative F minus our force of gravity in the x direction. So now what to do to find force of gravity in the x direction? Well, x we have F, m, g, and usually we have cosine of theta. But here, that's not going to be the case. Because it's an inclined plane and the system's like this, let's just draw an axis right here. And then this will be our y-axis. This angle here, gravity is being pulled on at this angle. So this angle here will not be equal to this angle. No, this angle here, theta, will be equal to this angle here. However, we want the angle right here. We're going to call this angle phi. So what it's actually going to be is going to be mg cosine of phi. Cosine of phi is going to be equal to cosine of 90 minus theta. And using our trigonometric rules, cosine of 90 minus theta is equal to sine of theta. So our answer is going to be MA is equal to negative F minus mg sine theta. This is because of what is called in geometry the vertical angle theorem. Moving on to number 43. Got to erase a lot of this again. Number 43. Number 43 is about two spaceships moving with the same speed v, so yard space, moving at the same speed v, same velocity v. And then these spaceships experience the same magnitude of force, F of 0, over the exact same time period for the same interval. For spaceship 1, this one, the force acts in a positive direction. For spaceship 2, it acts in a negative direction. It also tells us that the spaceship, for number 2, does not slow down. It slows down but does not come to a stop. So then it asks us overall which spaceship has the higher change in kinetic energy. So what we're going to use here is the work energy theorem, which just states that energy, change in kinetic energy, is equal to work. Well, we know that this ship is going to go further and acts the same force. So F of 0 with, let's call this big D, and for spaceship 1, and work of spaceship 2 is going to be equal to the same force, but with less distance traveled since it slows down but doesn't come to a stop. So we know work of 1 is greater than work of 2, so we know kinetic change in energy of 1 is greater than change in energy of 2. Therefore, our answer is A. Spaceship 1 has a greater change in energy because it travels further. Moving on to number 44. Number 44 gives the angular momentum of a platform on a disk before and after the disk drops, and it asks us how does the angular momentum change after the disk drops. I already said that, but my brain fart, it died. So it asks how does the angular momentum of the platform change? Platform. So we know to use the equation delta L is equal to torque times delta T, because it asks for changing momentum. When the disk drops, it exerts a torque on the bottom platform because we're only taking the platform as our system. If we didn't take the platform as a system, there would be no torque. But since there is going to be torque on only the platform, we know there is a torque and there's a change in time. So we know that delta L does change. So the answer is A. It decreases because the top of the disk exerts a torque on the momentum. This is going to cause a decrease. Question number 45. It's our final question for this video. Question number 45 asks, the force exerted on a box moving around a circle. So it asks us which of the following graphs best represents the force exerted on a block by the string as a function of the radius. Well, this is going to be, let's draw the diagram really quick. We know the force is going to be the force of centripetal acceleration, which is going to be equal to mv squared over r. So the force exerted on the block by the string, as it gets further, we know as it gets further, the radius gets further, meaning that the force goes down. So we're going to have an inverse relationship, and it's not a straight line. It's going to be an inverse like this, because we have the v squared here, and this would be r to the negative first. We just plot this on our graph. Just put in anything for your v values. So you could just do 1 for your mass, like 5 for your velocity squared divided by x. You'll see that it's going to make a graph kinda like this. So our answer is going to be D. Thank you for watching this video. I will have 46 or 50 out in probably an hour.